Systecon are experts in producing world-leading logistics software. The tool suite includes OPUS10, a comprehensive and flexible model that enables the identification of maximum availability for minimal cost by recommending an optimum spares assortment, repair policy and support structure. It is now one of the world's most powerful logistics support optimization programs. This demonstration describes the OPUS10 results and report capabilities. Once run, OPUS10 presents a cost-effectiveness curve for the defined problem. The curve is made up of a series of points, each one offering a different mix of spares and each requiring a different life support cost and providing a different measure of effectiveness. OPUS10 provides a range of effectiveness measures, and the shown measure is easily changed. For example, number of back orders, number of systems not operationally ready, or risk of shortage. If the location of repair analysis has been used, then each point also includes an optimum resource mix and repair or reorder policy for the items included in the LoRa element of the problem. The result window can also be used to compare the results of different runs. This has the advantage of providing a quick and easy way of identifying the impact of a change to a scenario. Let's say, for example, we want to consider a scenario where the transportation time between two sites is changed. Having amended the input file and run it, we can easily see the impact of changing the leg from the central store to the central repair facility from 120 hours or 5 days to 720 hours or 30 days. Clearly, the later option is less effective for the same investment, or more expensive for the same effectiveness. Perhaps you have a solution from a single item model where items have been scaled to an 85% fill rate or off-the-shelf satisfaction rate and want to see the difference between that and an OPUS10 cost-optimized solution. Well, although this is only an example, this is typical of most comparisons. By selecting one or more points, the underlying statistics can be identified, and by defining specific report objects, the amount of data shown can be easily controlled. In most scenarios, the most important output is the number of spares. OPUS10 not only details the number of spares, but it will recommend an optimum distribution as well. Here, for example, we have a number of items and their distribution between several sites. Note that in some cases OPUS10 may recommend a spares pool at some sites of 0. This is possible because OPUS10 has considered the impact on the end system of having to wait for an item from a higher echelon or for a failed item to be repaired, versus the cost of sparing another, more significant item. Included in the default reports is the cost-effectiveness curve, Logistic Support Organization, System Statistics, Station Statistics, Item Statistics, and combinations of each. The report may include intermediate results, that is, results that can be derived independently from the spares mix, or the report can include the results that are dependent on the spares mix, that is, point-specific results. An example of the intermediate results could be repair actions per year. Here we can see the expected number of repair actions per item, together with the expected number of discard items. An example of the point-specific report objects could be the life support cost summary. Here we can see how the life support costs have been derived and how they are broken down. Perhaps we wish to understand the performance of the systems at different locations. The cost and MOE by system and station report will provide the answers. As with the input files, it is possible to tailor reports to match the organization's needs. Columns can be hidden. Column headers can be changed, as can the number formats and measures if appropriate. The changes can all be saved and called back at a later date, or set as the default option. In addition to the report window, the analyst may choose to analyze a point in the analysis view. If selected, the problem is shown and data for each item at each location can be identified. It is also very easy to identify where different items arise and are stocked or repaired. The additional window allows cost drivers to be identified. The cost drivers can be measured against different attributes. For example, failure rate or repair actions. It's important to note that this is merely an overview of the model and many features have not been covered. For more information about our tools, please select another demonstration. Or for more detailed information about our products, please contact us or visit our website at www.systecon.co.uk.